Chapter 5, Section 1, Introduction to Polynomials and Polynomial Functions. Here are the topics we'll be dealing with. And in a sense, it's a little bit of a review from Chapter 1. So in the Math 105, they don't do Chapter 1. So this is sort of a review for those in 105. But this is what we will be ending. This is our last chapter that we cover. So let's look at this. Characteristics of polynomial functions. The graph of a polynomial function is smooth. That is, there are no sharp corners. So they're like curved lines if they're not straight. The graph of polynomial functions is continuous. That is, there are no holes or breaks in it. The domain of polynomial functions, unless otherwise specified, is all real numbers. What this means is all the numbers on the number line can be in polynomials. And the domain of polynomial functions, again, this is from negative infinity to positive infinity. This is the x values of our polynomial, in a sense, our horizontal number line. Again, a little review. Algebraic expressions and polynomials. A term can be a number, a variable, a product of numbers and or variables, or a quotient of numbers and or variables. Remember, the quotient was like a fraction form, and we had said that terms are usually separated in an expression by a plus sign and a minus sign. And a term that is a product of constants and or variables is called a monomial. So the prefix here, mono, means one number, monomial. And these are examples. 8 would be a monomial. W. Remember, there's a 1 in front that we don't write. And then here's the number. And there's a variable and another variable. Now, since there are no plus signs or minus signs between them, this implies multiplication, but this is just one term. Now, a polynomial, by definition, this is sort of like the umbrella of it all, covers it all. You could have a monomial or a sum of monomials. That is separated by either a plus or a minus sign. And these would be examples of monomials. Now, how many terms are here? Just think of it for a moment. 2. How about here? 3. Here. 1. There. 1. Here. Again, there's no plus signs. 1. Okay. Now, again, we're building vocabulary. We're talking about the leading term of a polynomial is the term of highest degree. Its coefficient, that is the number that's in front of a variable, is called the leading coefficient, and its degree is referred to as the degree of the polynomial. Consider this one. Now, my first question as we look at it, how many terms? In fact, I'll outline them for you. There's 1, there's 2, 3, 4, 5. Now, as we look at this, what would be the leading coefficient? Well, first let's do the leading term. Is the one of the highest degree? Well, this is degree 2, 3, 4, 1, 0. So the highest degree is this one. And that would be the leading term. And the leading coefficient would be in a sense, the 6. Now, since it's positive, we don't have to say it. But in a sense, it's positive 6. Okay, let's take a look at what they're going to say. So those are the terms we outlined. Now, what are the coefficients of these terms? Well, the coefficient was the number adjacent to the variable, next to the variable. And if it's negative, it includes the sign. If it's positive, we don't write it, but there is a positive sign there. And as we list the degree, it's the power that is on the variable. And if it's more than one variable in a term, we just add all the exponents within that term. But here it's 2, 3, 4, 1, and if there's no variable, it's 0 degree. So the leading coefficient was 6, and the leading term was 6x to the 4th, because this is the highest degree. Now, some other vocabulary words that are often mentioned here are the words monomial, and here what we're featuring is the prefix 1, mono. Mono is the prefix for 1. Binomial is the prefix, or bi, for 2. And then tri, the prefix for 3. After that, 4 or more, they're just given the name polynomials. But all of these are under the umbrella of polynomials. This is a polynomial of one term, has the extra special name of monomial. These are just one terms. 2 terms. 3 terms. Many terms. More than 3. Now, let's, while we're here, let's go and check out the degree of each term. We'll start with this one. The degree of this term is 2. This term, it's 0. Now, this term, we have to add the exponents that are on the variables. So the degree of this will be 26. 23 plus 3. The degree of this term is 1. This one's 5. This one is 2, 3, 0, and this one's 0. So this is 2, 7, 3, 1, 0, 2, 1, 0. Here it's 3, 2, 2, 0. Now I'm not putting that exponent there. I'm just saying this is the degree. 4, 3, 2, 1, 0, 6, 5, 4, 3, 1, 0. Now the questions sometimes arise, well, the first one is, what is the degree of a term in an expression? Well, we did that. Now the next question would be, what is the degree of the expression? And by definition, the degree of the expression is the degree of the highest term. So we look here, this is going to be 2, 0. This is going to be 26 because we had to add these together. The degree of this term was 26. So this as an expression is 26. There's only the 1. Here the degree of this is 1. Here the degree is 5 because 2 is smaller. We just pick the highest degree of any one term. Here this one is 3 of this expression. Of this expression, the highest degree is 2 of that term. That's the degree of the expression. Here it's 7, 2, 3, 4, 6. Notice in all of these, they have put the degrees in descending order. That is, it's the highest and then going down. This is descending order. Now, I think they're going to go over a lot of this too. So anytime the degree of a function is 1, we had this back in chapter 1 or 2, I forget, yeah, 1. We say the function is linear. That is, it would be a straight line. In quadratic functions, where you have a degree of 2 somewhere in there, that would be that description. It's quadratic if there's a degree of 2. If there's a degree of 3, it's called a cubic function. And if there's a degree of 4, it's called a quartic function. Okay, so these are words you can put in your notes as reference, and if you need them, kind of know how to get to the reference. Okay, now here's a very typical kind of example they're going to give us where they have this in function notation and they want us to do some substitution. So it's the function of x such that, and they give you this part. But this right here simply means they want you to use a -3 for the x. This is function notation. So let's set it up. We put the negative, we put our parenthesis, and what we put for x is -3. Then we put our cube sign, then our 4, -3 plus 7. So now notice we have no more letters. We have substituted -3 wherever we have x. So now we're going to cube -3. Well, you may recall that anytime you raise a power to an odd number, and if it's negative, it will stay negative. So this is going to be -3 times -3 is a +9 times -3 is a -27. So in parentheses here I would have a -27. But here this tells me to take the opposite of it. So this becomes a +27. This is going to be a +12. Well, no, it's a +4 times 3 will give me, so it's a +3 times a negative. Be careful of the signs. That's a -12 and your +7. Now remember, we could move these two together just to show you an old technique. Commutative principle. So this becomes a 34 minus 12 is 22. So remember, I don't know if we mentioned this before, but let me go over it. We have input and we have output. We are inputting a -3 into this function here, and our output is going to be 22. So we input this into this formula carefully, doing the substitution, watching the signs, and there's our answer. So there's the careful substitution, and there's your answer. Okay, here's another one we're going to take a look at. In a sports league of n teams, in which each team plays every other team twice, the total number of games to be played is given by this polynomial, n² minus n. A boys' soccer league has 12 teams. How many games are played if each team plays every other team twice? Well, this is the formula here. So basically what we're going to do is, where there's an n, we're going to put a 12. So 12 squared is 144, minus 12 is 132. So we have just followed this one, not too difficult, put in our 12 as n, did it properly, and our answer statement is that every, how many games? They will play 132 games. Wow, that's going to be quite a busy season. And there's the substitution, and there's the results, and there's the answer statement. Okay, here one perhaps a little more challenging. The average number of accidents per day involving drivers of age R can be approximated by this polynomial function. Find the average number of accidents per day involving 25-year-old drivers. Now you might say, well, what do I do here? Well, wherever there's an R, you're going to put a 25. So you're going to square the 25, times it by 0.4, and as we see in the next one right here, then you're going to multiply 25 times a negative 40. Again, you're going to get an answer there, an answer there, answer there, and then finally you're just going to answer them all, and you end up with 289 accidents for the age group of 25. By the way, earlier than this, the numbers are a little higher, and like 20, not a good group. They tend to be a little bit accident prone. That's why the insurance is usually so high on those folks. And there's your answer statement. Now here they want us to graph the polynomial function in the standard view and estimate the range of the graph. Well, fortunately, we don't have to do this one because we are not requiring you to do it, but let's take a look at what they have here. Again, you just put that in your calculator if you have a graphing calculator, and that's what it looks like. So what would you call that? Well, it's a curved line. It's a function to the third degree, and third degree functions often have this kind of shape. And the range, by the way, because they're asking us for the range, you may recall, are y values. So this is coming up from negative infinity down here, and it's going up to positive infinity up there, which this is another way of saying all real numbers. Now, what's the strategy for adding polynomials? Well, again, we did this in chapter 1. It's a little review, and it's combining like terms. So here, these are like terms because their variable has the same letter and same exponent. Now for this next one, as we look at it, we want to identify our like terms. So these and this are like terms. We have a 9 and a 13 are like terms. You have to be careful of the signs. And we have this and this are like terms. So you may recall earlier I said a good technique for doing this, well, let's take example C, is to write them in vertical columns. There's one, and there's another. Now we have a third and a third, so a negative 7w cubed, and this is going to be a plus w cubed. So in a sense, these are like terms, so that will give you 20 w to the fifth, and then here we're going to end up with a negative 5 w to the third. Now you could do it horizontally. I like this idea of doing it vertically. That way you've identified your like terms, and Remember, variables never change. It's only the numerical coefficients when you're doing this. Notice how long B takes. And there's the answer. Again, I like my method, but you can use others. So for something like this, writing it in like term form, so we could take away the parentheses since it's just addition. So I'm going to move this under here. So this is going to be 5x to the third. Now there's no of these, so sometimes you have to write it like this. Negative 6x to the third. Leave this open space since there's no term there. And then that would be where the second is. Sometimes you can do this. 0x to the second doesn't have any value. And then we put in our 7x, which is plus, and then a negative 2. So we've set up like term columns. So now we can put this here. 5x to the third. There is a plus 4x squared. Nothing under this, so we could put 0x squared there. Doesn't have any value. And we can put a plus 3. Now, these are sort of easy, and you probably don't need to do it here, but I'm showing you a technique for doing when they get a little more complicated. So this becomes a negative x to the third, a plus 4x squared, plus 7x, and a plus 1, as I just add my like term columns. Okay, here's another one. Now notice this one's a little bit backwards, but this has all the powers, 2, 3, 1, 0. So it doesn't make any difference which ones you write first. And in fact, I tend to want to write them in a descending power. So 2x to the third minus 4x squared plus 8x minus 6. And now I fill it in. This is going to be a plus 3. This is a minus 4x. And then this is a plus 2x squared. You have set them up in like term columns. Now you just add them. Well, let's do that right. So again, carefully watching your signs. Here's a negative 4 and a positive 2 gives me a negative 2. Remember, the variables don't change. And then here we're subtracting 4 from 8, we get a 4. Here we're subtracting 3 from 6, but the larger absolute value is negative. So you get a negative 3. And again, check your work. All right, let's go on. We're going to get to subtraction here very shortly. Actually, they were doing something different here. Now, here's a good example, and I'll pause it to set it up because the tape is running a little long here. Now, in this one, when you get to do them, I set this top row up first, and I saw it was missing x to the fourth, so I just put a placeholder there. Doesn't have any value. And then I put in my other terms, another placeholder. Then I went to the second row and put these values in the fourth, a second, and a 0. Fourth, second, and 0. Again, you got to watch that you copy your signs correctly. This was plus. And then here we had a new row that I started. Then put these others in the proper row. So now it's just a matter of going by and going 4x to the 6th. Careful. Negative 6, positive 10 will give me a positive 4x to the 5th. This is going to be plus 6x to the 4th minus 3x to the 3rd. Now here, notice you have a positive 2 and a positive 7. That's going to give me a positive 9 minus 8 gives me a positive x squared. Now you could put the 1 there, but we don't usually. And since there's no value for this, I'll just leave it blank. And then we add these up. So there's an 11 and 6 are 17. And there's your answer. Now, again, you might say, oh, it's so much time I'm spending doing this. But by getting the answer correct, it's well worth it. You want a strategy that will work for you. And look, our textbook is actually using this technique too. Okay, I'm glad they did because it's a good technique. Otherwise, again, you're liable to get lost. Okay. Now, we talk about the opposite of a polynomial. Well, it's what we would add to something to make it 0. We did this in chapter 1 when we did equations and the opposite of numbers, the integers. So here they're saying simplify this by writing the opposite of each one. So when there's a negative in front of a parenthesis, the only thing we do is take away the parenthesis signs and then change each of the signs inside. There's no more parenthesis. So this was negative originally. It's now positive. Negative, now positive. Positive, now negative. Negative, positive, positive, negative. Okay? Now, when you do subtraction, again, the same thing applies. This is subtraction because there's a negative sign followed by a parenthesis. They want us to subtract. So what do? Well, for each of these, what we're going to do is make this positive and then change all these signs. This will become positive. This now becomes a negative. This is a positive. This is a positive. And then line them up and do the addition. Now the tape is way too long, so I'm not going to do it because I've shown you the technique for it. Again, put them in like term columns. The key here is if there's a negative in front of a parenthesis, you can make that negative positive and then change all the signs. All the signs, not just the first one, as I've seen some students do. Change all the signs. And that's what they're showing you. And then you group like terms. And again, the same thing here. This will become a positive. Take away the parentheses. Change all the signs. Put them in like term columns. And there's your answer. Same thing again. Now, another way of thinking of this is, and I need a parenthesis over here actually too. If you write them in columns, which is my strong advice, and this is subtraction, you just make that a positive, make this a negative, and then you can get rid of this one now, this a positive, and this a positive, and add them up. Remember, you have to change all the signs. And that'll wind this up. Okay, well, you're going to be doing your practice and your quiz me's. And again, this is challenging. Give it your best shot.